Mark and I are going to be giving you a sneak peek of an upcoming handbook that we're launching. That's called the Commercial Software Distribution Handbook. So Mark is our CTO. I'm the CEO. We co-founded Replicated many years ago. Uh, so what is this handbook, right? And why do we produce it? So this is a handbook for ISVs aiming to distribute truly world-class self-hosted enterprise software. We wanted it to be really actionable advice for third-party application distribution. Um, we developed it through conversations with thousands of different software vendors, and we really aim to make it a pragmatic approach given today's technologies and constraints. So this isn't pie in the sky. This is what can you do today to offer really great self-hosted software. And why does it matter? Ultimately, we're providing an overview of the different challenges and solutions that ISVs face when they're tackling software distribution. Um, it is based around the commercial software distribution lifecycle. So this is a concept that we sort of pulled together over many years, but ultimately started to really talk about and publish earlier this year. And this distribution lifecycle should feel somewhat familiar in the sense that it was inspired by the DevOps lifecycle or the standard SDLC. But the commercial software distribution lifecycle is very much focused on the things that are unique to distributing enterprise third-party self-hosted applications, right? So even though some of these phases might be similar, there are unique things about each phase for distributed software. And so we'll go through each phase and we're going to talk about just a quick overview, and then we're going to go into some more practical advice around what this means in practice. So the develop stage, right? So you have to produce an application that is sort of both portable, so it can be deployed to different environments with swappable dependencies. Mark will get into a bit more about what that means. It's really important when you're distributing an application that different folks are going to be operating, that you build it with a real deep focus on reliability and resilience, and that you're leveraging the common packaging and templating patterns that exist in the market. So, Mark, I'll let you talk a little bit more about what this all means in practice.
Yeah. So, you know, obviously we all have to develop the application. And this is even before writing the Helm chart. And so when you develop an application that you're going to operate yourself, you kind of think about how do I operate this in this one environment? And so some of this comes down to making this a little bit more modular, flexible in different environments. And so use open source components instead of proprietary cloud services. If you think about using Postgres in MySQL, you might still choose to be able to run the cloud managed version of those, but like build it on top of things that you can swap out with something that's open source. And then that takes you to the next step, which is to take those components and allow them to be swappable with commodity hardware or commodity implementations of the service. A lot of your end customers may choose to run a database or an index or an open search or something separately, and allowing them to be able to do that. Reducing the architecture complexity. We definitely, in the Kubernetes world, the cloud native world, we definitely build a lot of microservice applications that allows us to move fast, it allows different teams to operate, and it's a good pattern to follow. But when we ship that into an on-prem environment, we have definitely seen that the more microservices you have, the harder it is to scale, to support. There is a lot more moving parts to that. And so by simplifying as much as possible, and yeah, you're not going to get down to a single like pod running, obviously, but like anything that you can do to reduce the complexity of that application is going to make it easier to support and maintain. Think about like least privilege. So, you know, everything from, making sure your application is going to be compatible with MTLS for pod-to-pod communication, not running root in all the containers is key. Design for multiple types of environments, like when possible, a pod should be able to have multiple replicas of it running that can actually handle a rolling update strategy or various update strategies in Kubernetes. Packaged with Kubernetes and Helm. And then the last one, and we'll talk more about this later, is to like add some open telemetry instrumentation into the application. Even though you're going to ship it into an on-prem air gap environment, it's still really key that while you're developing the application, think about observability, but think about observability from more of an open standard like OpenTelemetry.
Great. The next stage is really around testing. And so, what's unique about testing for distributed software is that you need to think about testing in all of these different environments, as well as different configurations, different components, different pieces that could be um, deployed by a customer. So, in practice, what this means is like new versions of operating systems or of Kubernetes will often have deprecated functionality, introduce new things, and the same can go for the different distros, right? So I think like EKS 131, Mark, what they do? They changed a default storage class or something.
Yeah, they made that so on a brand new install of 131, there is not actually a default storage class, so you have to specify the storage class.
Right. So like everything could be working up until 130, and then you expect it to work on 131, but because of this new change, well, it might not work. And so, you can find that out by testing those environments before your customers trip over these things. And this just, increases your install success rate. This improves the overall customer experience, and then just avoids, running into these problems in production. We also think you need to test various configurations of the application and the environment. So, if your application has, oh, you can use an external Postgres, use embedded Postgres, you want to test out each of these different pieces, different, types of installs and configurations, before you release new versions. And the same is true with these environments. Different environments can have different, configurations in terms of what's the CNI, what's the CSI, how does this thing handle that? So that you want to be able to test lots of different variety to make sure that your application is truly portable in any of these environments. This becomes even more true in these hardened environments. So, I think GKE is kind of an easy to use Kubernetes that people often will go to, particularly something like GKE Autopilot. But it has sort of unique challenges that are different than what you might see in an environment like OpenShift, right? And so OpenShift is going to be a little more hardened. There's going to be different security contexts and different requirements there. And the same is true for operating systems and environments that have, STIGs or CIS requirements. And then, each customer might have different types of network connectivity. So we always talk about online installs, but there's also, these man-in-the-middle proxies that customers are putting between, your application and any outbound request. There's air gap installations, and you need to be able to test those to make sure that your application will work as expected. And upgrade scenarios. So you want to test an upgrade from version 1 to version 2, but also think about what happens when you go from version 1 to version 5. And you just need to be able to validate that like there's a path for that upgrade, or if it's going to be a direct upgrade, that you're preventing the customer from doing that if there's some migration or something that needs to be run in between. Finally, you really want to integrate this testing into your CI and release process. So manual kind of QA on these environments is helpful, but doing this like in a more automated fashion will really allow you to have full visibility and sort of more confidence in each of these environments you're deploying to. So then we get into the release side. So the release stage, and this is about publishing artifact versions, managing the registry/directory, controlling the cadence of releases, notifying customers of releases, waterline, patching, etc. And Mark, I'll let you kind of dig into in practice what release really means.
Yeah. So when you're releasing, you want to put a version number on the software, and I think being as true to Semver as possible is really key because when an end customer sees there's an update available, they'll be able to that's a contract that they understand. And if it's a patch release, a minor release, a major release, they'll understand, if they need to schedule a maintenance window, they can just apply it or what. So follow Semver and be as true to that as you can. Gating access to images and artifacts with registry proxies. A lot of, most applications have private container images. And you have two approaches here. You can replicate it as a proxy registry that is tied to the license. The other option is to generate one-off credentials and manage those. And they're both fine. Like we think that the registry proxy is easier to do because you're not maintaining separate credentials and distributing those, and also having to remember to remove access when the license is expired or revoked. Um, Creating different um, packages for various formats. A customer might be running ARM or a Linux, 64-bit, Intel machine. They want to do a direct Helm install embedded Kubernetes, or a single Docker or VM, whatever that is. So thinking about that is both just the packaging format and the distribution, but also the architecture that they're going to be running it on is important. That goes all the way down to making sure that you're releasing multi-architecture images when possible in your application to support that. And then as you think about releasing it and documenting it and how to install it, there are multiple ways that a customer could pull this into their environment. They're generally don't expect everybody just to do a Helm install and pull images from whatever registry that you have. Some will, but like think about like HTTP proxy, no proxy variables, like in various stages of disconnected environments, all the way to the one where it's fully disconnected.
Yeah.
Grant, you want to talk about the
Yeah.
rest?
Yeah. I think, we kind of get into the next pieces, which is uh, ultimately we really believe in channels as the way to control who gets what when, right? So this is like allowing yourselves to be on monthly release cadence, quarterly release cadence, weekly, and customers can kind of pick which cadence they want to use, and you're determining who gets updates when. Um, and when it comes to actually these different install options, I think it's really important to guide customers about what options are available. But even as Alex talked about, like really setting a default, like something that, hey, we believe most customers should do it this way. And if you have a reason that you should take an exception, we want to hear it. And then we can give you a different path. But ultimately, providing a customer with a very guided solution, I think is really helpful for making them more successful. And then Mark kind of mentioned this earlier in terms of like customers are going to need to pull in different images and have different deployment um, kind of methodologies. So when you're releasing, it's important to understand like they're probably going to want to scan your images and the artifacts that you're providing for security for CVEs before they actually install it. So just kind of taking that into account and making sure that your install process facilitates that. Next, we'll dig into licensing. So the license stage is really about fine-grained access control to versions and images, delivering entitlements, and then signing and validating those entitlement values. In practice, this really means like you need a licensing server to manage these customer records and to connect that uh, to the licenses. So, a license is going to give a customer the ability to pool versions, to set an expiration date, to have all these different things that you want to do with software that you're selling. As Chuck illustrated earlier, this is a great place to integrate with your CRM so that you have different teams who can cross-functionally collaborate on these licenses. And then from a technical perspective, again, delivering entitlements, right? So that's values that your application can consume to understand, okay, what are the limitations of this instance? What functionality do they have access to? Consume that in the app, turn things on and off, sign those so that that information is somewhat tamper resistant, right? So now you have like a signature for what those values are. And then consuming all of that in your application, both in a way uh, that's going to be work for an online installation where you can check and send back information, but also in air-gapped environments that takes a little bit more work to make sure that those entitlements are signed for an air-gap release. And then we always say, this is kind of into reporting, but surface any license data to the customer. What are the limits, and then what usage are they at? Because some customers who don't allow any kind of outbound internet access or even reporting or even support bundles, if they see that, hey, they're limited to 100 seats, but they're currently at 150, right? We often say like, don't hard limit these things, but try to give reporting so the customers can self-report like, hey, we're at our limit, we're over our limit. Then you can actually go back and they'll say, hey, we want to be in compliance with our contract. Let's increase our limit. So you want to surface that to them in the application or in the admin console, wherever you can. Okay, the install stage. So this is where Replicated really started, was as an installer. And so we've spent a lot of time in this space, and people often think about us in this space. but it is just, one of the many stages that we're trying to address now and that we believe are really important to overall successful commercial software distribution. So, here you're really trying to meet the full spectrum of customer needs. And so this could be the platform, if that's Kubernetes, are they bringing VMs? This could be network access. We've talked a lot about air gap and proxy and online. This could be these different controls and requirements. Um, Ultimately, there's all these different things that you're trying to meet in terms of customer needs. And then you're trying to enable that customer to operate the application on a longer term perspective and to update it, et cetera. So in practice, this means there's a lot to do here. I think it starts with very clear communication to customers about what are the requirements for hardware or for network, for IOPS, for anything, right? This is you want to be explicit about what your application requires. And then you want to use automated pre-flight checks to validate that the environments they are supplying actually meet those requirements, right? So I can tell you how many times, a vendor has tried to do an installation or a customer tried to do an installation, and the problem was they provisioned too little disk space, right? Most of the time, you should be able to check that in a pre-flight check before they get too far down the path. Um, we also recently have really, Alex mentioned this earlier, but we've really kind of jumped onto this idea of tracking and understanding what your installation success rate is, right? That first try installation success rate, or something like within an hour of that first attempt, what percentage of your customers are able to get live? We think 95% is a very good goal. And we think that that's where most customers should be at, is able to install 95% of the time. And then again, guiding customers to an installation method that makes sense for them. Like, you really have to understand what their requirements are and then be opinionated and try to tell them, well, based on your requirements, we believe you should go down this path, right? You should leverage your expertise and give them confidence that if they do what you ask, they're going to be successful. And then you want to give them kind of alerts or notifications uh, around updates, and then guide them through applying those updates, right? Because, being able to stay regularly updated with the software is key to a lot of success, right? You're introducing new features, you're introducing bug fixes. So the more often customers are running new versions of your software, the more successful they're going to be. So you can even automate these updates if your application can handle that as well. Okay, and then we'll move on to the report stage. So this is one that we realized it is critical. I think when you look at how folks are used to running SaaS applications, there's so much more insight into what's happening with the health of each customer. And with a self-hosted application, there's actually both the health of the instance, right? Like, are the services healthy? Is this thing working the way we want it to? What's the uptime? But also, the usage. And it's really hard to get this information. So, customers are reluctant to, put in your Google Analytics tag, or, provide just streams of logs. And so you have to be very, very kind of pragmatic and thoughtful about what type of data, or more specifically, metadata, are you going to be collecting. So we think that the update check is the primary heartbeat that you can use to gain insight from customers. That does not work for air gap customers. So air gap customers, the support bundle that's created during a support ticket always contains a lot of information about the environment uh, and the usage that is going to fuel your support for that customer, but it can also be digested for this other reason of understanding kind of environment usage and kind of tracking that along the way as well. So we think it's really important to try to get minimal amounts of metadata. Again, I say metadata because you never want your cut to be sending true customer data out of these environments. It's self-hosted for a reason. The data should stay there. But some metadata about, like, is a service up? Is a service down? What version am I running? What version of Kubernetes am I running this on? Right? Things that are very relevant to the actual operation and your, like, ability to support that customer and make them successful is important to collect. And then, I think additionally, maybe with the opt-in about or opt-out option for a customer, is to understand usage data for core functionality, right? And again, this is usage metadata. You're not collecting what are the usernames, you're collecting how many users were active in the last 24 hours. How many projects did they, start? So it's sort of summary data to give you insights as to usage, and you roll that up as metadata about their overall usage. I think if you're transparent about you're counting some of these things, then customers can understand that like this is not sensitive data that's being sent off. This is true metadata. Um, and so when you have this, it makes it so much easier to know which customers are gaining success, to know which customers you need to lean into, where there's churn risk, and ultimately the full goal for you and the customer is to be successful in using your software. And so having some amount of reporting or insight is critical to that. Again, you can allow them to opt out, but I think by default, opting people into this, being transparent that you're sending back very minimal amounts of metadata, you'll get very high uptake rates. Very few people will opt out. Again, they can always just do an air gap install. None of this will come back by default. But if you do that, I think you'll end up with more successful customers, which again is the goal for every organization. Cool, Mark. I'll hand it back over to you for the support side. Um, I think this is an area where you've had a lot of leadership, so I'll let you kick it off.
Sure, yeah. The last stage here is once you've actually, installed it and followed these steps, then, it's running in the customer environment. You have to think about how you're going to be able to support it. And this is like thinking about how you handle escalations, how you kind of enable your customer to be able to perform some level of support of the application. Hopefully it's Kubernetes and they have some ability there. So the first step here is to really make sure you train your team on all the different environments they're supporting. Grant mentioned before that often we see like GKE is an easy to access Kubernetes environment, but then your customer's running it in, Azure AKS or OpenShift, and these are unfamiliar environments that behave differently. And you definitely want to make sure that you have that available and you've done some training on that, because when your customer reports a problem, and your team tries to reproduce it and they can't because if it's an environment problem, it's going to be really hard to debug. So like think about how to set those reproducible environments up, and then track the time to repair, time to resolution on the issues, and work to improve it. Understand what it is. It's obviously like have a goal and build towards it. Troubleshoot is an open source project that we created to really help in this area. It allows you to like codify collectors and analyzers. So you can collect data from the environment, from the machine itself, from the host, if it's an embedded cluster, or from the cluster, and then run analysis on it. So you're not just dumping a whole bunch of logs. You can include all the logs, but you can also scan for and look for known errors and known issues. And remediation is important. Grant, go back one slide again. I think you
Oh,
moved
sorry.
it back a slide. Yeah. And then, redaction is an important step of this too. So when you collect and then analyze and you want to send those logs off, you're going to want to redact any sensitive environment variables, passwords, things like that from the logs. Codify those. Like now that you have this tool, and you can shift it into pre-flight checks also, when you run into a support issue that needs escalation and you realize what the problem is, or when you run into an install time issue that took your team to help unblock, they were in the 5% and it took your team to unblock, try to codify those into a pre-flight check or a support bundle collector and an analysis. So the next time this happens, a customer comes with that same environment, the pre-flight check is going to warn them on that, and your team's not going to have to be involved in an escalation. Or the next time a different customer or the same customer has a similar issue, they'll be able to have a clear message about what the problem is. It won't be an escalation that your team is searching for. And then like think about how during the initial setup, the last two bullet points here, the initial setup, make sure that if it's a production environment that they've configured disaster recovery and you've verified that it's working, the data is showing up over there, test and restore early. Just make sure that it's properly working and they have alerting set up on that and they're monitoring that backup and process. And then, back when we talked about in the develop stage, I mentioned that, instrument your code with OpenTelemetry metrics. And even if you're not actively using them all, have it all instrumented in here. And then here you can document and help your customer plug in whatever they have. If they're running Datadog, if they're running whatever the tool is that they're running and they're familiar with, show them how to build dashboards, help them understand what the key metrics are to look at here, and then how to hook up their agents into your exported OTel data from your application so they can perform some basic level of monitoring and alerting so that they know like the disk is full. Oh, this pod is running at a high CPU and it shouldn't be. This is crash looping. Like every application behaves differently. Your team knows how your application is supposed to behave and how it's supposed to look. Help set that baseline and then just help. They're not going to, ultimately be SREs for your application, but you can share some of that information into dashboards, which is going to help with the MTTR. It's going to help avoid some of the issues and escalations.
Great. So that's a pretty good overview. So this book, right, or the handbook will come out in about 10 days. We're going to have it on as a Kindle book, and then we're going to have print editions available at KubeCon. So if you see us at KubeCon, make sure you pick up a copy of your handbook. And I'll see if there's any questions. Doesn't look like it. Cool. So with that, I think we will wrap up RepliCon Q3 2024. Thank you all for being here and really appreciate it. Thanks, folks.